Hi, I'm Robin. Script. Today we will write some katas, some small tasks, which we practice where we practice our skills, and maybe we will try something new, something from ECMAScript 6, something from ECMAScript 7. What I want from you is to write me in the chat. This should be a two-way conversation. I really like when people ask me about what we do or maybe have suggestions. I really suck at naming, so if you have good names, just write it in the chat. And I hope we will have fun because I really like these. What I do is that I use this site called Exorcism for finding katas. They have different language tracks. Right now we are doing ECMAScript. You can see in my profile how far we got. Last thing we did last time was prime factors. This is all, I mean, I haven't streamed all of them, but this is what I did, and it's been fun. However, last time, I'm not sure if you remember, we did the prime factors. This is the code we wrote, and that wasn't that nice. Actually, it didn't work, and it was too complicated, and that happens, I guess. I was thinking through that, and I actually came up with a much better solution, and I'm not sure why we couldn't find that the last time. So what I will do today is that I will remove this completely, and we will write new solution for this, which will be nicer, and I can promise we will have something which I would call is advanced because it does not work yet in current Node.js. Yeah. So let me go back what we need to do. I will quickly repeat. We compute prime factors of a given natural number. So prime numbers are only divisible by itself and 1 is not a prime number. When I will go to the test files, which is what we need, is that we see that we need this prime factors function, which has method form. That's a weird API, but that's what we go for. And some of the most interesting things are, for example, for 8, you see, we need 3 times 2 because that's the prime factors and how much they, I mean, the multiply of them. For 27, it will be 333, as you see. For some other numbers, it will be something higher. And here we have some really big number. We have to deal with that. Last time, the solution we wrote didn't work for these. All right, so it's 4. So what we need to do is we need to export a default function which exports an object. This is just the API they have, and we have a for method, and the for method receives the n, the number, and returns some kind of array, right? So what I will do here is that I will was it test watch? I will run the unit test server on the background, so every time we change something, we will see what has changed and if it works or not. So now when I run it, we see that, yeah, it returns empty array for 1. That's kind of coincidence, but it doesn't work for anything else. What is the trick here is that we will go from number 2 up till let's say n or n half, and every time we find a number that is divisible by which divides n, we will add it to an array, and if not, we will increment the number we are testing by 1, and we will go array again, which, as you might understand, is recursion. So we want to write a recursion, which is a really nice concept. It's very much used in functional world. So let's write that. So what we want to have here, we will somehow start the recursion, but we will write a function somewhere here. I will name the function prime factor. So I have it here. Nice. And what it will receive is the number we want to test. Then I need the factors we already have, which would be like by default empty array, but it would be the factors. And the last thing is I, which is the number we test against if it divides n. Yeah. Which means that at the beginning, I will write it how we started. We call prime factors with the n, the number we received. I think we can eventually make some smart moves like divide by 2, but then we would have problems with actual 2. So let's keep n right now. The next thing would be empty array. And the first number we want to test is 2, because 1 is not prime factor. Right, so we will start this. This will come here, right? And what we'll do here is that first thing we should do is we should write a stop condition. That means when does the recursion end? Which for us means, okay, so I will write, there will be a condition, and if that condition is met, we just return the factors. Yes. Right now we can write false because, false. We will think about a condition a little bit later because right now we are not sure about that, right? And then there are two possible options. I divides n or not. So I will write it as a ternary operator, I think. Yeah. So I will write return. Now I will write the condition, which is n mod I equals 0, right? So that means if it divides, we do something. If it does not divide, we do something else. So if it does not divide, that's the easier one. We basically pass all the arguments and increase the I by 1. I plus 1. So we test with the same number, we just pass the factors we already have, and just test the new number. So we will test if it's divisible by 2, if not, we will try with 3. Then we technically tried with 4, but since we have tried with 2, we know that it will not pass. That means if the number is not a prime number, its prime factors were already tested. So this will never ever like add a non-prime factor, which is great. So even if we test 8 here, the 4 wouldn't divide it anymore because we already have it. I will show you how that works. Yeah. So if the number actually divides that, then what it means? So first we do something here, but the most important thing here is the factors. So what we do, we create a copy of the array, and we basically just add one more item, which would be the I here, right? So now the array contains this I. Here we don't need, if I wrote n, that would be kind of wrong because we could cycle ourselves, and again, 4 would divide 8, but we don't want that. So I here write a divided by I, which we know will be a natural number. And we will know, I mean, it's a known simple mathematical proof, right? That if this is a prime, like prime factors of this number plus this factor are all the factors there are. I mean, yeah, that kind of makes sense, right? So we pass the number divided by its divider, one of the factors. Yeah, let's write it like this. And what we pass here, so I mean, we could pass I plus 1, but the problem would be that the factor can be multiple. So as we saw, 8 is divisible, like its prime factors are number 2 3 times. So we have to repeat it with the same I once more, right? So let me go through again. We test if I divides n. If yes, we add the I to the array of factors. We divide n by I and test the new number though. And we test this new number with I again, and we want to make sure if it's not multiple factor. If not, we just increase I by 1. So this works, but we need to stop somewhere, right? So at certain point, this recursion needs to stop. And that stop point is, when the I would be higher than n, then it doesn't make sense, like it can never divide, like a bigger number can never divide a smaller number. And I think that would be our condition here. So if I is bigger than n, then we just return what we had, right? Yeah, that works. Obviously we cannot write bigger, or equal, because ultimately once the I needs to reach the end, so it's in the last iteration, in the last part of the recursion, I will be equal to n. But we don't have to think about that. This should work, I think. We will see. I will save it as it is, and we will see. I'm saving. Yes, it works. Really nice. Also see that it returns empty array for 1. Yeah, sure, because immediately when we started, n is smaller than I, because n is 1, I is 2. That means we immediately return this empty array right here. So it works. You see here we have 2 skip tests. That's because these numbers are a little bit bigger, and we had some problems with them in the past exercises. So what I will do, I'm removing this X, enabling this test, and pressing save. Oh cool, this works. What about this really huge number? Will it like collapse, or will it go into like a, like, I don't know, something? I'm sorry, I know, I tested that. So this one I know, and what it does. Oh, maximum call stack size exceeded. Right, so what happens is that every time we run this function, prime factors, JavaScript runtime adds this execution into something called call stack, which is like a big queue of things, and he says you need to do this, and then this, and then this, and then when this one eventually returns, you will go through that thing back, because we have here the return. That means that this prime factor creates another prime factor, and so on. And JavaScript has some maximum size, like on the maximum buffer or stack, which it can accommodate. So that's kind of problematic, right? But, and now comes the great thing, and I kind of knew why I did that, is that I wrote this function this way in a how do you call it, ternary operator, right? Because I can take advantage of something which was introduced in ECMAScript 6, and as you see, it's not something which has something to do with syntax, like for example arrow functions. This thing is about optimization, and it's optimization of the engine. It's something called tail call optimization. Let me put this here so you can read it. So what we have here, I mean, here I'm not sure if you know Alex Rauschmeier, but I mean, he's a really cool guy who has really nice explanatory articles about JavaScript. So here you kind of see that normally you add things to the stack, but sometimes you can optimize it, and you can, like, instead of creating a new function, you can in certain sense append what needs to be done to the previous function, right? oh yeah, where is it? Yeah. So you just add things together in not increasing the stack, but just like appending, but it's just a little bit different, right? So you increase what is inside, not how big that thing is. However, that kind of means that the function needs to have something called tail call. Tail call means that you call a function as the last thing, right? So what we can kind of imagine is that instead of writing this prime function factors here, I could kind of repeat this function. I could like copy this whole and put it there. And that's kind of what the engine does. It puts the thing there instead of calling it. I mean, that's how I imagine that. And the great thing is that if I do this, it will optimize that. However, I need that the return statement returns returns a function call, which is this, right? So it needs this thing to be in so-called tail position. And as you see here, for example, with the ternary operator, here, so we have if x, call f or g, and return that. Here both f and g are in tail position. That's exactly what I'm doing. That's exactly what I'm taking advantage of. However, if this was OR operator, then f is not in tail position because it's not the last thing that needs to be executed. You need to execute f, and then you need to do something. I mean, you need to check if it's truthy or not, and then you call g or not. So then f is not in tail position. It's not like the last thing that would be called. However, in this case, this is like both of these calls are in tail position. Yeah, cool, right? But how that helps us. The cool thing is, as I said, in the current node, and by current node, I mean I have node 7.10. It's like really current one, the newest one. You can see that this thing is not implemented. It has this exception, so it doesn't work. But it is actually there, but under a flag. So if I pass a flag, I can run this. So first thing I need to do is to see how we call the test, where we have the scripts. Yeah, so we call jest. I mean, we don't have to probably call the rest one. We can call node and then pass the flag, which is harmony. Harmony is a flag that enables some experimental features, let's say. And then I just call the jest, which is in node modules bin jest. I think so, yeah. And then when I run it, it passes, right? I haven't touched the code. The code is the same, right? The code is very same, but just passing this option, which enables this optimization. Now I can, I mean, yes, in 14 seconds, milliseconds, which is kind of some time here because the number is big. But I can compute this just by writing this, let's say, smartly. I can do this, and I think that's great. That is really great. To show you that there could be some problems with that, but let's not look at it now. I think this is great. I already posted this solution to Exercism, and I mean that's why you have the 2 here. If you go to the prime factors, you see the second iteration is exactly what we wrote. I hope I tried to make it the same. Oh, I don't need this. It's actually an oversight. We don't need this. We just saw we don't have to have that there. And I also write here how that thing should be called. But I think it's a nice thing. Like this thing is called ECMAScript. You can barely see that, but this track, ECMAScript is not only about syntax things. It's also about built-in global things like set or map, and it's also about optimization. And we've just used that, so I think this is a great example. This is like a prime example. I'm so happy with that. And when I discovered that, I was also very happy. Cool. That was nice. I hope that you learned something. I hope that it's not very confusing. I will, when I think about it, I will paste this URL into the chat so you can see that if you want. And now I think we can move to the next task, and I have no idea what it is. So I will call this exercism fetch ECMAScript. So it will get the next kata in this track, and it's called Raindrops. Okay, Raindrops. So I will go to the directory and install dependency so we can work on that. Close these files and find Raindrop. Where is that? Oh yeah, Raindrop. That's the next one. Nice. So I will read me the spec, and when I'm in this, I will also create a file which we will write eventually. But now I can close the tree explorer and we can read what we have. Raindrops. Convert a number to a string, the contents of which depend on the number's factors. Oh, if the number has 3 as factor, output blink. If the number has 5 as a factor, output blank. If the number has 7 as a factor, output blonk. If the number doesn't have 3, 5, or 7 as a factor, just pass the numbers digits straight through. Oh, I guess you know what it is, right? That's basically FizzBuzz. I always hated FizzBuzz. I mean, I'm not sure if it actually shows something about the developer, but so many interview processes depend on FizzBuzz. I don't know. This is basically the same. Well, I mean, if there wasn't this third thing with factor 7, it would be exactly the same with different words here. And it's kind of funny because I actually did ask this. I think I once asked about the FizzBuzz. Yeah, I actually did. I need to. I'm sorry. Yeah, I'm sorry to the guy whom I asked. And the next question always was like, what if there was another number which would produce a new string? And I think someone in Exercism had the same question in mind. And I think this is a really nice exercise. Okay, so let's make sure it's the same. Examples. 28 has factors these. Okay, 7 is the important one. So it's just blonk, yeah, this one. 30 is 3 and 5, so it's blink blank. Nice. And 34 doesn't have any of those interesting factors, so we just get back the number. Okay, makes sense. Let's see the test to make sure. Okay, so what was the API? We have raindrops. We for some reason create new raindrops. I hate classes. I'm not sure if you are new at this stream. If not, you know that. If you are new, just know I don't like classes. I prefer functional programming. But whatever, I will keep this API. And it has a function called convert, which returns, which converts that into that string. Blink blank plonk, blink blink blank, plonk, blink blank. Oh yeah, that's like it. And then we should have this. Oh yeah, 105, blink blank plonk. Yeah, that's really nice. Yeah, this is exactly what is FizzBuzz, just with more numbers. So have you ever written FizzBuzz? I mean, what people do, I think, is that people try to write some smart thing. I mean, that's the biggest problem with FizzBuzz. It feels so simple that you say, oh, there needs to be some tricky solution. But actually there is like usually none. Like it will always look somehow either big or clumsy. And I guess that's what you need to know. Like if the person is able to write that, even though it kind of looks bad. So I've seen many solutions to that. And what I like the most, and I mean, this is so funny. I've written that once, is that you use something like a middleware architecture. So you have an array of functions and you go through them one by one, and each of these functions can add something to the resulting string, right? And the good thing, so how it works is that the first function checks if 3 divides the number. If yes, it adds plink to the string. And the next function does the same, but with blank and number 5, and the third one does the same with the 7 and blank. I usually wrote it with this and bus. And then you have the last one, which checks what is the current output, and if it's empty, it just outputs the number as a string. If it has something, it just passes that on. So it's like, I mean, it's kind of middleware. So it's a compose. Some people call it compose those functions. And the great thing is, the only important thing is the order of those, but you can add and remove them as you wish. Okay, this is going to be fun. I hope this is going to be cool. So convert is the name we need. Let's start writing export default. So I'm doing this not nice thing because of the API. This kind of gets rid of the new thing. Hi, Kochi. So what we do here, we receive the n, which is the number, and we return a string, right? That's the contract. But that's not what we want, right? So I will write here something. It will be an array of those functions, and I just call it FNS. That's not a great name. If you have something better, just write me. Otherwise, I will try to find something. Yeah, let's hope you will find something better. So these are the functions, and the API of these functions is that they receive the number we test, and then the output, which is like output so far. And they return, let's say, new output. I would say, yeah, that can work. Let's say like and what this thing will return will be an argument of output for the next function. Yeah, exactly. We call it. I said that it's middleware. Yeah, I mean in middleware you might have next, but we will keep it clean and just write it. So the first function is, as you remember. It's about this plink. Okay, I will copy that. I don't want to write that. It's free. Yeah. So we basically test if n is divisible by 3. I will write it like this because it's readable. Yeah, sure. Go check the garden. So we have these two options, right? So let's first say if it's not divisible, we just return the output as it was. If it is divisible, we add the blank thing, right, which I have copied. Yeah, I think I will write it in that nice string literal format. So just take output and then append blink to that, right? That's, as I would say, pretty clear. Now I will copy this 3 times. This one will test for 5, this one will test for 7, and I forgot how was that, blank plonk. So here would be blank plonk, right? So these function test for these vectors. But we need the last one, which has the same signature, but it does something a little bit different. So if it looks, again, it will have 2 branches. So first option is that output is empty. I mean, there are many ways how to do that. Here I kind of like would go with the native JavaScript truthy, falsy value. So if it will be an empty string, then it's a falsy value. And yeah, and if not, it's a truthy value. So If it's a true value, meaning it's not empty, we just output that like the same thing. So we just copy that. If it's empty so far, we just return n to, and we will convert it to string. I'm not sure if I should write the base. I think no. I mean, for toString it's okay. If you want to parse, you should always write the base. Right. So now what we need is we need to go through these functions and call them one by one, and then return what this function returns, right? So we have this FNS array. We need to go through them, and in the end we will have only one value, which means we need to use a reduce. Oh, I can't write. Reduce, right? And yeah. And we will pass the output. That would be what we are interested in. I will write the signature and then we will fill it. So the signature is the previous one and then the next one. Then we do something and we have the default value. And the default value, as we see, needs to be something falsy. And it needs to be a string, so it works here. And I will write a empty string. That kind of makes sense, right? Sorry. I will keep this here. And now what we need to do, so the next is this function. So we need to somehow call next with the number n we received here and with the thing we received previously, right? That's it, we just apply that. It will return a string, that will be the next ref, and we passed it. So, okay, I will remove those. It's still kind of long, right? Does it fit in one line? Is it good? Yeah, it's a one-liner, but I will make it a little bit nicer like this. That looks better. I save it, and I think this could work. I think this could work. So let's see that. I mean, I know I say, so this is not something we can like TDD. It's just like we start and it works or not. So I will, what was that? Yeah, run watch. And we will call all one. Yeah. So as you see here, we have these axes. I'm confident it will work. Okay, no, I mean, let's be safe here. I will, sorry, I will remove some of those only in the selection. So for the easy one, I will replace it. So now I test the single word once. I save it and it works. That's cool. Now it comes the thing when we have two of them, but it works as well. Okay, I mean, come on, let's do this. Let's just replace it everywhere. Now I've enabled all of the tests, and I'm about to save it. I'm about to click save. It works. Yes. So we wrote that. If you ever find yourself in a position when you write FizzBuzz, I am 100% sure that if you write something like we wrote here, I think it's a nice one. The interviewer would be impressed. I think it kind of makes sense. It's kind of easy to guess, right? You just have like function after function and you test things and you only care about that string in the end. And if something was there, you just add things. I mean, even if, yeah, I think I really like this. So now if someone comes, right, and says, okay, what about some other prime number? What is a nice prime number? 17, right? Just wrote long or whatever. Oh shit, I don't know what I want to write. Long, right? It will work. Let's see if it fails something. Oh yeah, it fails because this one is divided. It's divisible by 17. Nice. Yeah, I think this is really great. The good thing also is that this kind of function, if it has this signature, that means it receives one number and a string, can be taken out of anywhere. I mean, now I have them in this array, but they can be written anywhere. Right, but this naming isn't good. FNS is bad naming. That's bad naming. It's the other thing I don't like. Uh, so I mean, I could call it like a middleware functions. Yeah, I will call it middleware, so people know what kind of thing I like, what pattern I'm using. That's a better. I think that's the best one. Yeah, that's a good one. I like it. I really like it. It passes. I mean, also, I mean, this is why I write this. Like, this is so great. Yeah. Oh, today I wrote into the name of the channel that we will be using things that you might not want to use in production, and by that I was actually referring to the tail call optimization we saw in the previous example. But this thing, I mean, I want to see this in the production. Someone's asking, isn't Plur better? Like middlewares? I'm not sure. Like this whole thing consists of one middleware, and we kind of call it here. I mean, I want to keep things. I mean, here I want to keep things simple. Maybe we could have a function which would be called like apply middleware, which would basically did this magic we produce. But for me, middleware is like architecture, and this single thing is also middleware. It's confusing, I guess, but altogether it's like middleware, right? You have like, I mean, I don't know. Maybe it doesn't have plural. I don't know. I will keep it like this, but it's a good question. I mean, naming is so hard. You see, I mean, it was kind of easy to think about these. We kind of figure it out fast, and now we're talking about the naming. Yeah. Welcome to the real world of programming. Cool. I will submit this. Submit Raindrops JS. Submitting that. Cool. So this is the plural for arrays. Yeah, sure. I mean, kind of makes sense. So this is what we have. And now comes the great part, which is about accessism. We can see our people's. Can I somehow make this? We will see if you can see that, but I don't like this thing to be that high. And let's see what our people did. Let's check this guy because he has 2 iterations. That could be interesting. And I don't know, Jay, that's a good name. So what we have here? Oh yeah. Okay. So this is basically the same approach we had, but it's like imperative, right? So you start with this empty, and then you either you add things if something is passed, which is I mean it's cool, it works. Here you like look if it's empty. Maybe it's good to be expressive here. I don't know, but yeah, sure, it's like a cool solution, except, what is this? Oh, I see. This is the thing I wouldn't like much, because, like, first, if val is empty, you append to it, and you return this. I mean, that's a good thing, but whatever. And then, of course, I always prefer, if you are doing some type conversion, to be expressive. So I always write toString. I know that this plus would convert it to a string, but that's not nice. That's not nice. Okay, that's kind of okay. What was the first iteration? Yeah, that's interesting. This guy wanted to do some optimization. Oh, that's interesting. That's interesting. So first, it was set to the number as a string, and then if it is divisible by one of those 3, it goes inside this function where it works as we saw before. That's kind of interesting. That's interesting. What about this one? That's yeah, that's the same thing again. I mean, maybe you can't think about other things. But I like this more because these functions are basically what we wrote, like these single purpose functions you can like copy and replace, and then you just output what you had. So we basically wrote the same thing. I mean, I kind of can I click on this? Oh yeah, it's difficult for you to see that. I'm sorry about that. I always forget. I'm tempted to, yeah, let's write that. It looks good. This is good. I mean, if you don't want to possess the restrictions we put on ourselves, then I think this is a good solution. So let's be fair. This is kind of a good one. I would like this. I would like to see this at an interview. If I ever ask the question, please don't. I mean, if you have the power, please don't give the FizzBuzz exercises. I don't think it helps. Have you ever like received FizzBuzz as a task at an interview, like you personally? I would like to know that. I think it's the single most overused exercise at the interviews ever. Cool. That was interesting. Let's do another one. What is that? Allergies. Oh, interesting. So again, oh, double L, allergies, install it, close this old project, find allergies, readme, spec, create new file. I should write some, first I don't know why they don't include the empty file. It would save me some time, right? Allergies, allergies.js, cool. Given a person's allergy score, determine whether or not they are allergic to a given item, and then full list of allergies. And their full list of allergies, okay? An allergy test produces a single numeric score which contains the information about all the allergies the person has that they were tested for, okay? The list of items and their values that were tested are X1, peanuts, 2, shellfish, 4, strawberries, 8, and so on. You can see that the values are powers of 2. What a coincidence, right? So if Tom is allergic to peanuts and chocolate, he gets a score of 44 because 42 plus 2 is 42. Now, given just a score of 44, your program should be able to say A, whether Tom is allergic to any of those allergens listed above, or the allergens Tom is allergic to. No, a given score may include allergens. Allergens? I mean, that's a weird word. I will search for that. Can I see it from here? No. Not listed above. Yeah, sure. So we can have allergens which have scores like something else. Right? Cool. Cool. Yeah, this is again something I would say rather common. Usually it's called flags. So what do you do? And it kind of works with this thing is that you imagine a number to be written as a binary, which means 0 and 1s, and so and then the position, like this 1 or 0 says if person is allergic to that thing, right? So on the first position, which is like, yeah, here from you, like the first position is X. If it's there, you write 1. If it's not there, you write 0. The same for peanuts, which is the next position. And as you write it like this, these numbers, I mean, this together will be a binary number, which you can express as a number in a decadic base, and you can use it. I hope it makes sense for you. And the good thing is, actually not that good thing is, but now I have in mind 2 solutions, and I kind of think we can write both of them. So the first one is using one weird feature of JavaScript, which is called bitwise operators. I will show you so you know what it is. It's called bitwise, oh, I have it here, operators. And bitwise operators, you see, you write them like 1 ampersand, 1 pipe, or whatever that is, like these things. You don't use them every day. These are not very often used, and they somehow feel very low level. You know, it feels like writing C. I've never written in C, but that's how I feel it. That's how I think it feels like. As you see here, you take a number as, instead of like a number, you take it as 1 and zeros, right? And then you can, what is this? Yeah, let's see this thing. This is really nice. This is good. Let's look at this example. Allergy. Allergen. I will look at that. That's a good one. We said how to read that. Okay. I can actually now, I should be able to, come on. I have this, I mean, I have force touch. My force touch should be able to do that, right? I have allergen, I force touch it. I can't force touch it, why can't I force touch it? I hate this. No, what is this thing? Lookup, yeah, ow, yeah, great. Allergen, okay, thank you. We'll say that. Back to the flags. So here we have two numbers, 9 and 14. That's how you write them in the base 10. In the base 2, you write them as 1001 and 1110. We can ignore these 0 before because they're not important. And then we have this special operator, which just takes only the places where both numbers have 1 in them. So you see, the only position they have, but they both have 1 is here, right? Is the 4th position. The good thing is, if I go back to the task, the number 34, I can test if on the 2nd position, meaning peanuts, it has something, and it would, right? I can do that with all of these. And there would be one way how to do that. So we would just do this. Yeah. The error option, which I kind of like a little bit more, I guess, I don't know. No, I mean, my error option would be, we would have like a mapping, right? We would have X, 1 peanuts, 2 shellfish, 4, and then we would take the number we receive, convert it to the string, like kind of this string, and then we would look at the positions. I don't know. I really don't know which is the better one. So I will start with this one, with the string one, because I think it will be a little bit longer, but in the end a little bit more expressive. So I will start with that one, and then we can do the one which is kind of tricky one, right? I mean, I wouldn't want to use that one. Okay. Oh, sorry, I need to look at the API. So we have allergies. We receive, new allergies, the number, and we have to provide list of the allergies. Yeah. And then the other way around, you ask if for a specific thing. It's annoying. But yeah, sure, whatever. We can do that. So export default function, you receive, I will again call it n. I like to call numbers n. And then you have this function called list. This could have been so nice interface, yeah. And we do something here. But for that, I will first create an array of these things. And now the naming is good. It's allergens, yeah. Now the naming is cool. And it's an array of these things. Let's do some magic replacing. So I replace, oh, I'm sorry, I can't see that. Star space. Yeah, like all of these removed, And then I want to remove space, bracket, digit. Where is that? Digit. Does it work? No? Oh yeah, and oh, I need to enable regular expressions. Where is that? Here. So it's bracket, space bracket, digit, and another bracket. Oh, there could be more of those digits. Cool. And I want to replace this with, oh no, I forgot that. Oh my god, oh my god. Yeah, I forgot to write these, man. I forgot to write the end of, the start of the strings, but it doesn't matter. We can replace two spaces with two spaces and yeah, replace, or now, cool, yeah, works, man. Ooh, regular expression is done. So we have the list of them, but the order is important because this is the 0th position. So it's like a 0, and we know that 2 to the power of 0 is 1, right? The same works here, right? This is like a position 2. That means it's like 2 to the power of 2, meaning this is 4. 4, my bad. That's good. So we can take advantage of the index of these numbers. So what we do now is that we take this number we've received and transform it to string in a base 2, right? I will save it and run it so we see what it returns. But now it will return somewhere. Yeah, now, okay, not that good. Let's try something more interesting, like maybe 8. You see, we receive this number, which is like a 8 in binary. That's cool. I will also enable this and this when I'm at it. So what we can do now, okay, we will now write a series of transformations, and we will see if it works. What we do now is we need to reverse it. So what was the last thing? Oh, sorry, we can't reverse a string, right? We want to turn it into an array. I like this expression, how to write, turn things into an array. And reverse it, so now what was the last thing is actually the x, right? That's what it is, 0 or 1. Now what we do is we want to know at which positions we had we had 1s. So what we do is we create a map and we take what we have there, which is like the digit and the index of that digit, right? That's important. So the first one would be 0, and we turn it into an array of, and that's no surprise, is digit and index. So we remember both of them. That's important because the next step is to filter those. So what I do is that I receive this digit and index, and what I want to do is that no, not yet. We can make it, oh no, let's skip this, let's do something else. So now we have the digits, but I don't like the digits. So what I would do is that we receive this digit, but we want it to be number. Oh yeah, so we can do this, that's really good. We can just write number. This will convert the string, which includes a number, to the actual number. Then I can call map boolean, which converts that number to true or false. So as you know, 0 is true and 1 is false. That means that here I don't receive digit, but I receive the bool. Cool. Now I can actually filter that because I'm only interested in those where there were 1, which means the bool is true. I receive this array, I distract it, and I want to only return the bool, right? I don't need an index. So I can either write it like this, which is good, or I can remove it completely. I will keep the underscore, so it says it's an array of 2, but it's a pair actually, but I'm only interested in the first thing. Now you see why it was important to remember this index, because if we have just filtered for the true, we'd have an array of true, but we wouldn't know at which positions they were at. So now we have that. We can distract the indices. So now we have these, but we know that this bool is always true. That's what the filter does. So we don't care about that. And the thing we care about is the allergen on the position index. Yeah, that should work, right? Let's save that. Oh, it works. It works for these. That's good. That's good. Let's see how far we get. For 2 of them, it works. For another 2, it works. For almost all of them, it works. For all of them, it works. For 0, oh, that's going to be interesting. For 0, it doesn't work. Yeah. Oh no, sorry. Now we have this new function called allergic to. This is the other thing around. Yeah. Okay. We need to implement that. That's a new function. I mean, this writing isn't that nice. I mean, maybe I will refactor that. Yeah, let's just write a. Let's try it like this. I mean, it could be better, but let's keep it like this. So what we need to do is that we receive a number, but we want the question to be asked otherwise. Well, so first thing is that we can construct this array and then just look if this peanuts is inside it or not. So we can just reuse that function. I kind of like that. The other option, yeah, I kind of think that's good. Let's do that. So that kind of means I will abstract this. I like that. Let's call it list. I mean, let's not complicate things. It receives n. It's a pure function now. That's good. And it returns everything we had here. We just write this. I will run the. Oh yeah, we have something's wrong here. Oh yeah, this is not. Yeah, everything's passing still. And what we do is that we take this list n, and we can includes. Is it includes? I always forget that. That's the new ECMAScript 6 thing. Huh? Oh, sorry. And he will receive name. Let's save that and let's see how it works. Yeah, it works. So it's called includes, right? So it just looks if it's there. Maybe it's not efficient, but it looks good. This save works. Oh, something's wrong. Oh yeah, man. No, actually, what is wrong? Undefined. Oh yes, good one. So we have a number bigger than 255, and what we do here in this list that we take all of it, and it's possible that if you don't have it in the allergens, it's undefined, but nothing is easier then to do this map boolean. No, I can. I don't know. I want to filter. Sorry, filter boolean that removes all false values. For example, undefined. Let's save that, and it works. We have that. I like this. It's kind of long. I think that the next solution we will write, and I think we should write both of them, will be shorter. So I'm stopping this. I will submit it, and I'm looking forward to writing the next solution. So submit. I will post this into the chat, but I will not open that because I want to try the next solution with the flags. Okay, so I will remove this list, and I will keep the allergens. I guess I think I will need this because, yeah, I need that. Either way, I remove this, and I will see how it goes. So now I want to use this bitwise operator, and as you see, the AND, right, which kind of returns a value if it's true, if it has something in common, and 0, which is false for something which is 0 if it doesn't have anything in common. So for the list, what we do is we take these allergens as they are and we go one by one and we check if this flag is true for them. I have that in my mind, now I have to explain that. We will see. So I take all the allergens, and it's good to write them with the S, and I didn't have that in my previous solution. Oh, you should be checking my naming. I was kidding. So you take all the allergens, and what you do, oh, this is going to be so simple. You just filter them, that you take the, you don't care about the name either. You just care about the index of that thing, and you check if the number n has something in common with 2 to the power of index. Is it it? Oh, sorry, I need to implement that. So just write true, it will fail. Is it it? Is it it? That's, oh man. So yeah, I'm not running that. Watch. Run all. Yes. That's okay. That I knew it would be shorter. I knew it would be shorter, but not that shorter. Okay. And the allergic to, we receive the name here, and what we do, oh yes, we just write the allergens. Index of, right? Index of that name, if it's there, and then we check. No, 2 to the power, yeah. Okay, let's write it like this. So this will get us the index of these things. For example, 1 here. We do the same trick. We create we find the power of that thing in that, and we just look if the n has something in common with this. That's it, right? Let's save it. Let's see. No, something's wrong. What's wrong? Why is it wrong? Maybe let's write. Oh yeah, maybe I don't know. Is Atom the new Sublime Text? I don't know. To be honest, I never used Sublime Text. For me, it didn't click. I was using Vim for a really long time. Oh, when we had that, I guess you all read this article about Stack Overflow. That the question, the question how to quit Vim is one of the most searched questions ever, and like every 20,000 search is for this question, and people have so much fun about that. But honestly, the first 2 times I run Vim, I had to restart the computer. Uh, the first time, I mean, we had one PC at our home, just one PC, right? And I got this magazine with a CD with live Linux, and I tried that. I was trying that. I was actually like playing with Linux for a while, and in the magazine they said something about open Vim with this command. So I opened that, and it was in one. It didn't have Windows. It was like just one shell. Maybe you could switch them, but I didn't know how. So I just were in one user shell. I opened Vim. I couldn't search the internet because I didn't have a phone back then, right? I mean, we only had one computer. I couldn't search the internet because I was loaded in that Linux. So I had to restart that. I went to the Windows, to the internet. I searched how to end Vim. And then I tried again. And I find out that you have to press WQ or Q exclamation mark, right? Yeah, exactly. You're right, cool. But the thing is that for me, it didn't work either, right? I tried to write that. So I went back, restarted again, went to the Windows, read about Vim, and discovered that you need to go from the input mode to the comment mode. So I went back, tried it, and on the third attempt, I was able to close Vim. Yeah. That was really something. I remember that till today. I was pressing Control C, right, and it didn't work. It was so weird. But so I totally. And it's great because today, whoever has this problem, just types how to quit Vim, and I'm sure that the very first thing you will see will be this answer, and you just click on that and you can see it on the phone and it will solve it. So I love internet because of this. Input comment mode is total garbage, says Lucomatic. Yeah, I understand the benefits of that. Oh yeah, Ram, I restarted PC. Welcome in the club. As I was saying, after that I was using Vim for like, I don't know, good 5 years. It was my primary editor for 5 years. I got to use some of these commands and everything. I never were good. I never was good in any measure. There was so many things I didn't know. But I understand why it was good. Then I switched to WebStorm and I enjoyed the IDE. And now for the past, it could be a year actually, maybe less than a year, I've been using Atom. And I kind of like it. It's simple, I like that. So, but I understand why people like Vim. What was the question? Oh yeah, Sublime Text, I skipped that for some reason, don't know why. Let's go back because we have a solution that doesn't work, it's not a solution anymore. But it's weird because this thing actually broke the rest, right? So if I write here, sorry, true. Oh no, whoa, what happened? Something really bad happened. It worked before, right? You saw that. You saw it worked. What would we? Oh yeah. I copied. I didn't copy. I cut. That was bad. Yeah. Okay, my bad. So let's get back and I copied. I didn't copy that. Yeah. Save it. Oh, and this needs to return boolean. Save. Yes, we are there. I like it. This is good. This is good. This line, that's something. This is so great. I posted. I will fine tune this, and then I will show you the difference in these iterations. But it's great. So here I converted it to boolean. Maybe it would be better to just write 0 is equal to this. Maybe it's more expressive because a result of this is a number, so it kind of know that. Yeah, I can't change this much. I guess this is good. This is good. That was the only thing I want to change. But it doesn't work. How is that? Oh, that's good to know. I didn't know that actually. Oh, it's not equal to 0. Oh my god. Yeah, because if it has something. Whew. Yes. So good. Interesting thing is that the comparison has a preference over these bitwise operators. I don't use that often, and this is surprising to me. So yeah. But I kind of like this. I kind of like this. Yeah, yeah. Let's keep it as it is. Let's quit this and let's submit that solution. And now we will have 2 submissions. This is the link to the second solution. Great. And let's see that. Let's see the comparison. I mean, that's really great. I mean, yeah, that's really cool. Let me see. This is better because we can switch. So this is the solution we wrote as the second. It doesn't fit well, but it's still kind of short. And this is the previous one. You can immediately see the difference, right? Like it's so much more in here. It's it's fun, yeah. It's great. That is great. Okay, so this new solution is better. I mean, this is nice, but I mean, I can imagine that one day when I look at this, like in, I don't know, few years, it can be difficult for me to remember how these bitwise operators work. Yeah. Maybe we should have abstracted this into a function and then reuse it here. I don't know. I don't know. But maybe we should have done that. Yeah. Now I think we should have done that. We have still some time. Let's do the third iteration. Let's create a new function. Yeah. Think about name. And it receives, what does it receive? It receives n and power and returns this thing. And it's here, and we call this power. Yeah. And now is a question for naming. I will speak about the phone a little bit later. I will just call it like a has mask, because with these flags you can have mask. That's like a naming. We can look at that. I mean, you can search that. So has mask n comma index like this, and the same here. Or we can remove that. That's good. So has mask n comma allergens index of name. Yeah, that's better. I like this. That's much better. And because the previous one was a little bit long, I will also push this on a new line, and this one as well. I mean, we didn't have to do that, but you saw that in that editor on Exorcism, it looked bad. Let's submit that. So this is it the same? No, it's not, right? It's a new. The number is new. The how do you call it? The hash is new. Cool. But if I reload this, I see the third one. Yeah, now it perfectly fits. I like this one. Cool. Okay. Oh, so the question I have here is again about the editor I use, and I'm so like I spent some time with that. So first, I use Firacode for these litiges. That means, you see, this is basically these two letters, characters, equal and greater than. And if you put them together, it creates this arrow. The same works with non-equal, equal. You can see that, like, I will write it. So I have three equal signs. If I put two of them together, it's just two vertical lines. If I put three equals, it's three vertical lines. So you can easily distinguish that. I think there are a little bit more of those. Some of I like would be, how is that? I think this is also a little bit different. It's not that much seen. It's called, I think I have it somewhere. But yeah, I think you have it, yeah, I have it in my description in the Twitch profile. Oh yeah, good one. Yeah. So when I write an Elm, I get this. Wait, it doesn't work here. How is that? Weird. It works in Elm. I get this. Okay, I will show you. So it's Vercode is free. It's open source, and here they have this really nice picture. I hope you can see it. So as you see, instead of like this, you have this and this. And I mean, I know so many people who don't like it. And to be honest, I didn't like it either. I mean, half a year ago, I hated that. I hated that. But now I kind of get used to it. I really like the arrow. And then you have some nice things in Elm. It also looks good. Yeah, I kind of got used to it, and now I kind of like it. But I totally understand people who don't like it. Yeah, Aram, yeah. What I did also is that you might see, and that is something really good, is this const, right? It's not normal const, as I will write it. Like, you see how it changes? Now it's like a normal monospace, whatever, like it looks good. And I put the T, it switches to this, and the same thing is with let, I think, and maybe some other, I don't remember what everything I have that. There's this font and I really like it. It's called Operator Mono. Operator Mono. And that's a really nice font. Maybe I can find some images. So yeah, let's see, view image. And you see that this is like the signature thing for that font, this L and S. And he had the ref, and he doesn't use it for const here, but that's a signature thing. The only problem with that is that this font, and I will show you because I was looking at it. I mean, it looks really cool. I mean, when you see it in the presentation, you definitely know it's called Operator. But as you I think that you think, oh yeah, you saw it, you see it already, it's a paid font. It's a font you have to pay for, and the amount you need to pay for is that, I will make it bigger, $180. Yeah, exactly. Pay $180 for your font. To be honest, I was thinking about that, but I don't know, just don't know. I mean, it looks good, but it doesn't look that good. So what I did is that I found a different font, which is called, I don't know the name, but I will show you. It's called Space Mono. And I changed the atom settings. So it, on certain locations, like for example the const there, replaces the Vercode with Space Mono and makes it look good, and makes it, I mean, goes into the italic. I think I can post this setting somewhere. And then, as you saw, the Space Mono is again a free open sourced font, and it has a really nice italic, and that's what I use. Yeah, exactly. That operator is fancy. I mean, to be honest, I like it, and many people use that. Like for example, Dan Abramov uses that. I'm sure. Harry Roberts started using that. It looks good. I mean, when someone uses it in the presentation and you see this, you know that person really cares about the fonts, and that he probably paid some good some good money for that, or stole it. I don't know. I don't want to do that. I saw that you can download it, but I didn't want to do that. I don't support stealing. Cool, cool. That was nice. Thank you for asking. I like to speak about these things. Let's go to the next task. Strain. Nice one. Close, close, close. And yeah, this is the same thing as always. Where is that? Strain. Readme. Strain spec. New file. Strain.js. Yeah. 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 That's. Oh yeah. I almost forgot. Install the dependencies. Yeah, Leukomatic, 170. I think it's actually $79, but yeah, yeah. I mean, I like fonts. I have some books about typography as well. I mean, I think I appreciate it. I also bought fonts for my presentations, but they were like, I don't know, $10, $15 for the whole family. So I would say cheap. I know that if you have a design studio and you design like billboards and you pay good money for the fonts, but for a coding font, but I mean, yeah, the truth is that you spend like more than 8 hours. I mean, if you are just spend hours every day looking at the code, so I think it makes sense to invest into that and make it good look. For me, the investing meant that I just found some setup which works for me. But for some people, it means spending $200. Yeah. But I mean, I don't judge that. I think it makes sense. I mean, if you really like it and it makes you more productive, or like I don't know, something, then I understand that. You should go for that. You should go for that. Yeah. Let's go back to this. Let's write this. I want to write code. I mean, it's nice talking about the fonts, but the code is better. Implement the keep and discard operation on collections. Given a collection and a predicate on the collections elements, keep returns a new collection containing those elements where the predicate is true, while discard returns a new collection containing those elements where the predicate is false. That sounds like a filter method, doesn't it, right? Write two functions, each take a function and list. One of them will return the list of items for which the passed in function is true, and the other will return the items for which it is false. For example, given a collection of numbers 1, 2, 3, 4, 5, and the predicate is the number even. One, yeah, what? Function may be called keep and discard, or they may need different names in order not to clash with existing functions or concept in your language. Ah, okay. Keep your hands off that filter reject. What shall I call it? Functionality provided in your library. Solve this one yourself using other basic tools instead. Okay, you got us. Okay, so I guess it would be too easy. It would be just like, yeah, it would be too easy. I'm not sure how else we will do that. I mean, when I want to operate on arrays, it's difficult. I don't know. We can map them. I don't know. We will. This is interesting. Like, I mean, so if the only thing we are not supposed to do is filter, then we can still use something like, I don't know, map, and then reduce. I mean, reduce is basically the same, and you just keep the things you have. I guess we will write and reduce and move to the next things, because this one doesn't seem to be it doesn't seem to be challenging, right? I mean, maybe you have some idea, but for me, I don't know. Okay, so let's see. What is the API? You have strain, keep, and straight discard. Yeah, okay. Let's copy that. Export default Was it like that? I think so, right? So yeah, you strain.keep. Oh, I hate this. So you just, okay. I think we can just export const keep. Let's try it. I'm not sure if it will work. I get sometimes confused when you use it like this. And let's say it works, and you receive array and predicate. This is, sorry. Sorry, I have this lamp here so you can see me. It's getting a little bit dark. Yeah, we'll see. And the predicate. Sorry. What we do. So as I said, let's keep it easy, I would say. So we do the array dot reduce, right? So I will write again, how do you call that? The signature of that. So it's pref next, I always call it like that. Then we do something, and the initial is empty array, right? And what we will do, we go through the array, we receive the next item, we run the predicate. If the predicate is true, we append it to the previous. If not, we don't. So it's going to be a little bit not interesting. So predicate on next. I can put it on the same line here, just like this. So if the predicate passes, then we copy pref at next. If it doesn't pass, we just return pref. Save, yarn, run, watch. That's, oh, watch. Yeah, of course I wanted to write that. That's what I meant, yeah. Let's go here in the strain. Oh, it doesn't work. Haha, haha. We did something wrong. Again, this is a predicate. Yeah, well, what is that? Can I read properly keep of, yeah, so yeah. So the problem we have is actually something different. We need to export default, and this needs to be an object, I think. Let's see that. Is it like this? Something's wrong. I wish, yeah. Can you just write export default and then think? No. Oh yeah, sorry. I think you can, right? Yeah, it works. Okay, I made it unnecessarily complicated. So we just have this, and I'm pretty sure it will work. It works here, 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 also here. Oh yeah, this one is testing the discard. So okay, let's make things more interesting. Let's do this one a little bit different, because I mean, obviously what we could have done is just write the same thing but write the exclamation mark here, or switch these two lines, and that's it. We would have it. So I will write it a little bit differently. I still think it's basically the same. Oh, I can, yeah. I wanted to write a map which would transform it to the, like the same thing I did with, if you remember, with the allergens, like go through that, transform into pairs of item and Yeah. Now that's a bad idea. That's a bad idea, I guess, because in the end we also had to use filter. So let's say I want to filter something without using filter, obviously, and without using reduce. That's gonna be difficult because the rules are, you have basically three functions, right? You have map, reduce, and kind of filter. And as I view it is that map is when you want to end up with an array of exactly the same length as the original one. Filter is when you want to end up with a subset of that array. And reduce is basically for anything else, but it means that you have one value which can be another array, but it doesn't have anything to do with like the shape isn't connected with the original one, right? So, but yeah, let's see the MDN array, and let's see what methods are there. Maybe we will have some nice idea about it when we see these methods. Concat copy with entries. That doesn't help us. Every yeah, filter, we can use that. Find index for each. I mean, yeah, but I don't like it. I mean, we could have had a array and in for each change that, but it would be mutation. That's against my principles. I'm not doing that. Index of join keys, map, pop, push, reduce, right? Doesn't change. Shift, slice, sum, sort. Huh. Sort. That could be a nice one. We can sort. Can we? Maybe we can't. I was like thinking maybe we can put the truthfully ones at one end and the falsely one at the other end, and then kind of split it, right? I'm thinking about it. It would be kind of interesting. Can we do that? Sort. Yeah, I think that could be. That's actually a good idea. I think it will be fun. We still have to do something like after that, but at least we will have this truthfully, and yeah, we will see. Why is it moved? Yeah. So the compare function you can pass in sort takes two values and then returns a number, if I remember. Yeah, exactly. Let's try that. Let's try that. That's good. So we do this dot sort, and we pass a b, and we do something, right? What we want is that the values that are true in the predicate, we want them to be in the beginning. That means they are kind of smaller in the ordering criterion. So if A passes the predicate and B not, we want to return -1. If it's the other way around, we want to write 1, and if both of them pass or both of them don't pass, we return 0. Oh yeah, that's something. That's kind of fun. So we take A and B. Now we need two things. We have I need naming. So predicate. I mean, can we say predicate passes? So let's call it A. Pass A. I don't know. Pass A. Let's call it like this, and that's going to be the predicate called on A. Const pass B is exactly the same thing called on B. Really nice, really cool. So these are true Boolean values, at least I hope. And what we can do is if pass A and not pass B, we return -1. It means that A is passing, B is not passing. If it's B passing but A not passing, we want to switch them. So it's 1. And if it's anything else, we return 0. That's cool. Oh yeah, it works for empty. that's not something interesting. Now we want to have numbers which are bigger than 10. Okay. Oh yeah, which are not bigger than 10. That will pass as well because that doesn't remove any values. And now, yeah, now it will fail. Finally. Yeah. So now we have the values passing on the left, but we kind of want them to be, I will switch that, so I want to have it the other way around. I want the one that does not pass on the left. I'm saving that, so now you see that the number 2 is here. We don't know how many of them. Okay, cool. And what do we do next? Now we take one value after each other until we find a value for which the predicate is true, and there we stop. Not very funny, not very fun, but did we change something here? I don't know. Man. Oh, I know what we can do. So now in this, I mean, I'm playing with that because this is a stupid task, right? So what we have here actually, let me format that, this is like sorted, and then we can get the number, and the number we can get by the reduce. So we get, let's call it amount, and that's, we take the original array and we reduce it, but now it's a little bit different, so it will be at least some fun. Pref, next, we return something, and the initial value is 0. Cool. What do we do? What we return is we either add 1 or we don't add 1. So if predicate next, let's write it somehow nicely. I mean, predicate next, we can write it like this. So if it passes, we increase the number, so it's pref +1, otherwise pref, and now we can do return sorted dot splice 0, amount. Maybe it would be ±1. I always forget that. Okay. Empty array. Where is empty? Is it splice? I always forget that. Splice. It's slice, right? Slice. Yes, slice. Okay, still not. So I will try to return the amount. Here I want amount to be 1. It's 0. Why is the 0? I want I want to count the number of times the predicate is not true. Ooh. It's still 0. Oh yeah. But here it's, yeah, 3. Yeah, yes, good. Yes, it works. Yeah, okay. At least we had some fun. Still works. Does it work on erase? Yes, it does. That's it. So it works. So let's make it a little bit nicer, and we will have time to maybe to do one more. What I like about this is that I will take this sort function and write it somewhere here. Const something, whatever. We will put sort by a sort that passing last. Yes, that's a good name. So we sort it, and then we have amount of passing. It's a function that receives something. We will find what we need. We need the array and we need the predicate, yeah? And it returns this and this. Cool, cool, I like that. I mean, in the thing what is possible. Yeah, okay. How do you like that? It doesn't work. What? Predicate is not defined. Which one? Which one? Which one? Predicate. Oh yeah, in the passing last. So we need, oh yeah, we need to carry that. So we need to pass the predicate as the first thing, predicate. It needs to have access to the predicate. Save, works, yeah. Okay, it was something funny. This is the thing you don't want to have in your production code, right? We all know how to write a filter. We just had some fun, something, I don't know, you sort slice. I mean, this is kind of similar to this, but whatever, just keep it as it is. I just get submit string. JS, cool. This is the solution. You have it in the chat. And I am curious, what did the other people find out about this? Like, what did they do? So this is the solution we have. Let's see our implementations. This one is interesting, and I don't know, let's go somewhere down. Oh, not so many people did this, right? Maybe this one. So this one did the for each thing. Oh, interesting. He abstracted them to a like a command method, which is bool, which means like to try. 0 means to keep the order. 0 means to switch the order. Okay. Oh yeah, 1 or 2. I don't like this bool, but whatever. And then for each, oh I see. He either pushes that to one of these arrays or the other one, and then depending on this bool, he or she, or like this solution returns this or that. Okay. Okay, that's kind of interesting. So it will always do that. Okay. What about this one? Oh, that looks interesting. So we have keep and discard. Keep is the reduce, and it's basically it's basically the same with one exception, and that's this thing. I will show it to you. I don't like this. It's exactly the same point. Like exactly, you see it's after the question mark. These two things do the same. I will write the same naming so you see how it works with the same naming we have. So the thing is that you push into the array, but the problem is that push does not return the new array, right? I think it returns the thing you pushed into it, which you kind of don't care about. So in order to keep it a simple ternary operator, you need to do this comma expression, and that means you will return the pref which you changed here. This is hacky. I mean, whenever you use comma expression, That's wrong. Like, I mean, here we could like do that, but in your production code or like, I don't think like anywhere, do not use commas unless you want to do some really, really dirty tricks. Like that's so dangerous, and I think that most of the linters disallow that. Sorry, that's the same, and then the discard. Oh, that's interesting. So he makes keep, but the predicate returns false where the previous one was true. Yeah, that's actually good. That's actually good. That's good. That's good. I like that. Why didn't he use concat here? I mean, concat would be much better. I will write to him. Just quickly, I think that's what we want to have is that we want to have AC concat L. I think that should be. Maybe after the stream I will write him something more, but now I think this, let's make sure it looks good. Yeah. No, it's definitely not performance. Performance is not that. The push is not that very performant operator, I would say. I mean, yeah, sure, I'm pretty sure that it will be translated into concat, and concat is really good. So natively, I think it would be fast. Oh yeah. We need to find. Yeah, you see, it just makes it the concat, so I think it would be pretty fast either. Like both of them would be fast. Nice, nice. Let's go next. Yeah, we can do more today. Today is good. I feel good today. I do like that so far. Strain. Nice. Nice one. Sorry, strain. When I say strain. Atbash cipher. Let me close that. I want to ask you about the microphone. Now I'm using the microphone in the camera, and I'm not sure if you can hear me well, or maybe if it picks some other noises, if you have some echo or something. I was thinking about buying a new camera, a new mic. So if you can give me some feedback about the microphone, it would be great. I would like to know how you hear me. Well, I mean, do you, for example, here, I mean, I have MacBook 15-inch, and for some reason they have some problems with heating. So the fan is spinning kind of fast. Do you hear it? Oh yeah, that's it. Maybe a little noise in there. That's probably it's because of the spinning fan of the computer. Yeah, well, I'll try to find something. I think, oh, I have this really nice microphone. When I got talking about that, it's called Blue Snowball. Some of you might know it. Yeah, it looks like this. I have it at my parents'. It's a really nice microphone. So I think I will bring it and I will try to stream that one. It is a really nice retro look. Yeah. That could solve that. I like that one. I recorded my podcast with that. Yeah, Oram writes, concat creates a new array. Yeah, that's you are right. It takes more memory. That is true. That is true. I agree with that. Okay, I think that you might be right that if you are really performance-wise, then the push could be a little bit better, a little bit more performance-wise. Performing. But for me, for my purposes, writing functional mutating array is wrong, yeah. And then what I always tell myself in these situations is that how big the array would need to be to really feel that performance drop, right? But I mean, yeah, that depends on you, and you are right. You are totally right that concat creates new array, and that could be memory inefficient. Good catch. Atbash cipher. Yeah, we'll need to create an implementation of the Atbash cipher, an ancient encryption system created in the Middle East. And the Atbash cipher is a simple substitution cipher that relies on transporting all the letters in the alphabet such that the resulting alphabet is backwards. The first letter is replaced with the last letter, second with the second last, and so on. Yeah, sure. And Atbash cipher is for Latin alphabet would be as follows. Cool. It is a very weak cipher because it only has one possible key, and it is a simple monoalphabetic substitution cipher. However, this may not have been an issue in the cipher's time. Ciphertext is written out in groups of fixed length, the traditional group size being 5 letters, and punctuation is excluded. This is to make it hard to guess things based on word boundaries. Encoding test gives GVHG, decoding gives test. Decoding GSV, oh yeah, whatever is this, gives the quick brown fox jumps over the lazy dog. Okay, okay, interesting. That one is interesting. Nothing interesting here. Oh, we have some source on the Wikipedia. Let's try if we can do it without it. Now see the test what we need. We have simple encode, no, yes, OMG, yeah. Yeah, with spaces. Oh, so we don't care about spaces, I see that. When it's long, we do this, what is the word? Chunking. Yeah, we chunk it by 5. The numbers are kept as they are, but we get rid of the punctuation, and sentences is the same, and the same thing, the same. Yes, yes, yes. Okay, okay. Let's try it. So we have basically one method called encode. That's all the API. I don't know why we just can't like write it like this. This would be much better API, but whatever. I will write it in this way. I think it would be easier for us. So we have the encode method, and we receive the input. Let's call it input. That's a good name, right? And we do something with that input. Well, this will probably fail. I hope it will fail, right? And it does fail. That's good. So again, we have this alphabet. I think I can copy this. We need to find the index here and then take the same from the sorry, this the index from the back, right? Yeah, yeah, okay. Okay, so let me alphabet. Is it how you spell alphabet? I hope so. Alphabet, yeah. Alright, I just didn't copy that, man. That's bad, fellows. So we have this, and I would say we can immediately split it so we have an array of those characters. Oh, Zurles, welcome, hi. What font are you using? We've been talking about this. It can be like less than an hour ago. You can find it, but the shortcut is called Furacode. I just show it like as I said. It does these cool things, so find it out. It's really cool. We split it. We have the characters, and now what we do is we take the split. Sorry, we take the input Um, we can split it as well, but I kind of think we should first replace, because replace is kind of easier than mapping and then removing, I guess. No, let's do it functional. This is not functional. Split again by characters, and it will be just a chain of things. So we split, then we filter, we receive a character, and we want to know if it is, if it's a word, it's a word. See, I mean, this is not efficient because right now we don't, we would create this every time we run it, but we can make it more performant later. So we test it now, it should be only letters. It means that the punctuation should be gone, white space should be gone, and we have only letters. And then we do a map, which would be, what is the name of that? It's not switch. It's map. I'm bad at naming. Substitution. Yeah, let's go with substitute. Substitute. Yeah. Let's call it substitute. That's what we do. And then we, right now I will join it with nothing, but later we have to chunk it by 5. And the function substitute receives a character, and what we need is we need to find the index here and then take the index of the length minus that, I guess. So it will be a longer. Const index is alphabet dot index of C. Good. And then I always forget how these alphabets, like the array, works when I want to do minus index. Does it work? Does it work? I always forget that. I'm not sure. Let's try it here. So I have array 1, 2, 3, 4, and I want the element minus 2. It doesn't work. No, I hate it. I hate it. It should work. This should be working. This should definitely be working. But we can do the trick. We can write alphabet dot, and now we might need to add or subtract 1 or 2. Yeah, exactly. We need to add, no, -1 minus index. Save. Yes, we have that. Cool. That's kind of good. Now we can go and enable this one, this one. Oh, this one fails. Oh yeah, because it's we don't care about lowercase and uppercase letters, but that's good because it's just a new map in here, and we take C and C to lowercase. Oh yeah, it's sorry, it's to lowercase. Yeah. Save. That's it. Cool. This should be the same. That works. Long words. That's where it stops, right? And this is the rest is basically the same. And now I actually saw a problem with this, but we will see later. So now we need to chunk it by 5. So Lodash has method for that. Oh yeah, Zurless, yeah, I feel you. Exactly, it should, if you pass -2 to the array, it should get the second from the back. Sometimes it works, like with the split it works, with this one doesn't, I don't know. Oh, it's not split. Whatever one. Yeah, split? Split. No, split. Slice. Yeah, it works with slice. So here, instead of joining that, we need to create these groups. And it will be a reduce, definitely a reduce. We call it to, or well, just call it chunk. And the default value is empty array, and then we will join it with a space, I think. Yeah, with space. And we need to implement this function chunk. Right now we will make it fixed for 5, but later it could be made variable, and the number could be received as a first argument, like the in carrying. So it's pref next. So what we do? So we want to have an array of strings which are, yeah, let's make it an array of strings which have 5 or fewer elements in them. So what we do is that we need to find the last one, right? So it's so the last one, it's array Yeah, that's how you get the last one. That's not nice. So you have the last element. If it is there, if not, we probably want to make it an empty string. Right? That means at the very beginning. Oh yeah, but we can start with that. Let's start with that. So we always have that string, that's the last one, and now there are two options, right? I will write the condition and we can see it. So if last dot length is smaller than, oh sorry, you can't pass something. I'm not sure what it is. There's some spam control, and it's, I don't know. If you want, you can write me on Twitter and I will read that. Yeah, sorry. I don't know. You probably have some special symbol in it. It doesn't like it. You can, as I say, write me. Oh, can I somehow not? What is unblock? Okay, now I might. Once again, I want to. Okay, I'm sorry. I don't know how this works. Can you write me? Can you write me on Twitter? You just got banned for 10 minutes. Sorry. I have to look at that. I don't know what was the problem. So if the length is smaller than or smaller or equal to 5. No, my bad. If it's smaller than 5, we add it, right? That's very differently. If it is 5, we add to the we return. Okay, let's write return. So depending on this, so if it is or not, if it is, we return pref, and then we add the next, which is the character, and it will be a string, and will be everything will be there. If not, oh, what did I do? That's wrong. That's wrong. We don't have to do this. We have ECMAScript 6. Oh my god! I totally forgot about that. So we have. What did I do? That was wrong. So we have this thing head and tail, right? Yeah, we can do that. So you have head and tail, and you get pref, but you need to return it because we need this one will actually be tail and head. I'm not sure if it's the correct naming, but I think you know what I mean. you have head and tail, you reverse that, what you had, and now if the tail length is 5, what you do is that, you get the pref, then it's the tail, and then is the next one. Cool. If not, you take what was there, like you always do that, kind of. So you take the head, like all of the ones before that, then you put tail plus next. Save. Yes, it works. Can't say it's a good one, but I think it's not that bad. So this chunks it. Let's make it. No, let's not spend time with that. And we have one more thing I think do, which is this one. Okay. So we have a problem with the undefined. What is this? Undefined. Okay. I guess. Oh yeah. What? Oh yeah. The tail needs to be by default empty string. Will that solve that? No. What? Head can be by default. But how did that happen? We have this empty undefined. How can you get that undefined? What has happened? In which way you would get undefined? In this, right? Tail, but next has to be always defined. That's what we have here, right? We have this letters in here. And tail is also always defined. We know about that. Now I'm getting confused a bit. Oh, I see that now. I see that. Yeah. So we actually still, yeah, it doesn't work with the numbers. Yes. So here in the substitute, we look for it, and if it is not there, right? So, where to write that? Yeah, let's write it here. So, I don't like this, but we will see. So if it's not there, just return it. So if alphabet includes C, not, return C, and I can put this into like here. I think that's better position. Save. That's it. That's great. We have something wrong here. I'm not sure what it is. We somehow switched this. I don't know what happened. Oh. Yes, Oram, that's exactly what it is, yeah. But now we have some problems with my Levy is here. What? Little more. We have some wrong. Yeah, I have some problems here, right? I will try something. No, it doesn't work. So now this chunk thing doesn't work as intended, because for some reason it changes the order of the first one, like the last one seems to be okay, but this one is for some reason switched, and is the same here. This one is okay. This one is also okay, but then levy, it's like some weird order. Why is it like that? Let me look at the chunk here again, right? So you reverse it. You had tail and head. I think I don't need this. It's empty. Then I want to write. Oh yes, yes, yes. This head is. Yeah, yeah. My bad. My bad. Of course, we need to reverse the. Yeah. So, for example, here we don't have to do anything. We can just write. We can just basically copy what we had there, but here we need to reverse it. What? That seems to be the problem, but what? Because we have to reverse it twice, right? Let me write it at here again. Had naming again, naming, right? What do you have, like whatever I call it first, and that's head dot reverse. You need to again reverse it. Then you put what you had there and save it. Oh, come on, why doesn't it work? What did I do wrong? Uh, hmm. Oh, I know what is that. Haha, haha. Because if this is, if the, can it run like that? Because if this is a string, it can somehow be also, let me write it like with concat, which I usually like. Pref next, yeah. Tail plus next, yeah. Okay, something is wrong here. I didn't know that. I thought it would be okay. So this thing is there twice. Why? I mean, here we copy that. If tail is no more than 2, we just copy together. I'm not sure what I did here. I did something wrong, and I can't find where was the problem. So this should work, but for some reason these two things are switched. So are these two. I need a small thing to work, and it will be done, and it's it. And I got stuck here. Chunk. Yeah, I mean the problem is that I can't write like head and tail the other way, but if I reverse what I have there, which is an array, right? That's definitely an array, so of string, so I reverse it. meaning what was the last thing will be first one. I will take it as it is, take the head, reverse it again, so it's in the origin, I call it first. So I have first, then I have the tail, and I can expand the tail by the next. That should work. And it kind of works, but it switches the order of the like in some really random order. Okay, let me think about that. One more. Head is always an array, so I can reverse it. Tail is always a string. Right? Yeah, yes. I guess I will have to console log these things. And then I will only do it with, for example, this one. And I will console log what is tail. No, I will need to know what was pref and what is tail, what is head, and what is first. Would that be too much? So I can't console log here? I should be able to console log. Oh, yeah, here it is. Oh, so tail is empty, head is empty, first is empty. Then I have M. Oh yeah, sorry. This will not help us. I need to disable. Oh yeah, I can write it. How is that? Only is F. Yeah, F fit. Yeah, cool. So we only have this one, and we can see it. G, GV, GH, GVH. Yeah, good. Then we add the M. But that's wrong. Because the M should be here as the last one. How is it possible? I have this thing which is here, and then I put next. That's weird. And I should receive this the other way around, right? The pref should be in the correct order. Why is it not in correct order? Yeah, oh, yes, I see that. Reverse is this stupid thing that, but that's what I wanted to try here. This should create a new array, right? And it works. Yeah, thank you. Thank you, Aram. Yeah. Yeah. That was. You see, mutations are bad. That's what I've been telling you all the time. So what happened here is that we return this array like here, but the first thing we do is that we reverse it immediately, and it will reverse the original one. Like it's the same pointer, right? It points to the same thing. I hate it, so we copy that. Yeah, I hate that. Yeah, reverse is one of those which also returns. But man, okay, let's have last check. But it looks good. This is good. Substitute is good. Chunk is. We need to remove this. Yeah. Yeah. I like it. I'm going to submit that. Right. Cool. And this is the solution. Let's find here and let's see what some other people did. Oh, somebody wrote something to us. Let's try this one. And oh, I like this image. Oh, yeah. So what did they do? Oh, this is shorter. Why didn't we think about something shorter? Replace. Yeah. So just take letters to lowercase and then map. Yeah, it's basically the same thing. Join, replace. Oh, this is good. That's the trick. This is the trick how to chunk. This is the trick. Okay. But then you have to trim it. Okay, I kind of like that. What about this one? You split it, you reverse it, okay. So you have these two. Oh. This is not nice. This is not nice, guys. You have to like. I mean, it kind of works, but I don't like that. Yeah, but you can transform it. Yeah, I don't like the solution. I see what they did, but yeah. And they also know about this trick. How is it possible that everybody knows about this replace trick with chunking? I don't like that. That's weird. Okay, guys, that was fun. I think we did. Did we did 4 tasks today? I think we did 4. That's cool. And oh yeah, we did 4 and the one from the previous one. So that was really productive. I enjoyed that. It was cool. We did some really nice tasks today. I hope that you like that. If you have any questions, write me in the chat, write me email, write me on Twitter. If you want to do something, write me as well. I was thinking about doing some game because there are these systems where you program bots in JavaScript and then they compete against each other. So I was thinking about doing that. There are some MMOPs which do that as well, and I think that could be fun. So if you like that, just let me know. Or if you like these katas, I would like to know that as well. So I mean, I would welcome any feedback. Also, write me about the sound. We already talked about that, but I think we can make it better. And I hope that you had fun. I certainly did, and I hope that I will see you some next time. Thank you very much for joining, and see you.